Have you ever stopped to consider why understanding different types of data in mathematics is crucial? Well, it's like trying to navigate a city without understanding the significance of various street signs. Data in mathematics is the language of our information age, and being fluent in this language opens up a world of opportunities. Let's consider the vast fields of science, economics, and business. Their backbone? Data analysis. Scientists use data to test hypotheses and make discoveries. Economists analyze data to understand market trends and predict future scenarios. Businesses use data to make strategic decisions, optimize operations, and understand their customers better. Understanding data types in mathematics allows us to organize, analyze, and interpret this vast amount of information efficiently. It's like sorting a mixed pile of puzzle pieces into their respective images before starting to put the puzzle together. It makes the process a whole lot easier and more meaningful. So, let's delve into the fascinating world of data types in mathematics. First off, we have categorical data. But what exactly is it? Well, imagine you're in a room full of people, and you're asked to group them based on their hair color. You might end up with groups like blondes, redheads, brunettes, and so on. These groups, or categories, represent categorical data. In other words, categorical data is data that can be sorted into different categories. But these categories don't have any specific order or priority. Now, let's dive a little deeper. Categorical data has two subtypes, nominal and ordinal data. Let's start with nominal. Think about the names of fruits: apples, bananas, oranges. These can be grouped into a category of fruits, but you can't really say that one is greater or less than another, can you? In other words, there's no inherent order to these categories. That's what we call nominal data, categories that cannot be arranged in any specific order. On the other hand, let's think about a race. First place, second place, third place. These are also categories, but they have a very specific order. The runner who finishes first is faster than the one who finishes second, who in turn is faster than the one who finishes third. This is an example of ordinal data, categories that can be arranged in a specific sequence or order. So, to sum it up, categorical data is like a basket full of different fruits. Each fruit represents a category. If the type of fruit doesn't suggest any order or ranking, like apples, oranges, and bananas, we're dealing with nominal data. But if the categories suggest a ranking or order, like first, second, and third place in a race, then we're dealing with ordinal data. So that's categorical data for you, simple, isn't it? But let's not stop there. Let's peel back more layers of this fascinating world of data. Tune in for our next segment where we'll dive into the realm of numerical data. Stay curious, my friends. Now let us shift our focus to numerical data. Numerical data, as the name suggests, is data that can be measured and represented numerically. This type of data can be manipulated using mathematical operations, giving us insights we can quantify and understand more precisely. Numerical data is the cornerstone of many scientific studies, business strategies, and yes, even your day-to-day decisions. Let's delve a bit deeper into this, shall we? Numerical data can be broken down into two subtypes: discrete and continuous. First off, let's talk about discrete data. This is data that can only take certain specific values. Think of it as the exact change in your pocket or the number of students in a class. You can't have 2.5 students, can you? No, you can't. That's because these values are distinct and separate, hence discrete. On the other hand, we have continuous data. This is the type of data that can take any value within a certain range. It's like the weight of a person or the height of a tree. These measurements aren't confined to specific, distinct values. They fall on a continuum and can be any value within a specified range. You could be 165.5 centimeters tall or 165.52, and so on. The possibilities are, theoretically, endless. In essence, the main difference between these two subtypes of numerical data is the nature of their values. Discrete data is like the steps on a staircase, each step representing a specific value, while continuous data is more like a ramp, where any point along the ramp is a possible value. So, what does this all mean? Well, understanding the difference between discrete and continuous data and knowing when to use each is key in interpreting and making sense of the numbers around us. And that, my friends, is numerical data in a nutshell. So we've covered quite a bit today, haven't we? Let's take a moment to recap and reinforce what we've learned about the fascinating world of data types in mathematics. We began by understanding the importance of data. In essence, data is the bedrock of information. It's the raw material we use to construct knowledge, make decisions, and understand the world around us. Whether we realize it or not, we interact with data every single day. Then we dove into the realm of categorical data. This is the type of data that can be sorted or grouped into categories. We learned that there are two subtypes, ordinal and nominal. Remember, ordinal data has a specific order or ranking to it. Think of your favorite ice cream flavors ranked from 1 to 5. Nominal data, on the other hand, doesn't have an order or ranking. It's like the colors of a rainbow, each unique but not inherently better or worse than the others. Next, we ventured into numerical data. This type of data is all about numbers and can be measured. Just like categorical data, numerical data also has two subtypes, discrete and continuous. Discrete numerical data can only take certain values. Think of the number of books on a shelf. You can have 1, 2, or 3 books, but not 1.5. Continuous numerical data, however, can take any value within a range. Consider the height of a tree. It could be 10 meters tall, or 10.5 meters, or even 10.51 meters. Understanding these types of data and their subtypes gives us a solid foundation for interpreting and analyzing the information we encounter in our daily lives. It's like having a secret decoder ring for the world. Remember, understanding data is not just about numbers. It's about making sense of the world around us. Thanks for joining me in this exploration of data types in mathematics. Until next time, keep exploring.